we are given the inner diameter, okay? And this is 1 5/6 of an inch. They're also telling us that the width of this band is 1/8 of an inch. So what they want us to do is determine the outside diameter, which is this. This is the outside diameter. They're giving us this. They're giving us the diameter of the inner, and we also have this. So the diameter would be the middle diameter, which is 1 5/16, but plus twice this piece and this piece. So twice 1/8, but this is multiplication. It's not 2 1/8. Be very careful. It's, which is, this is actually 2 plus 1/8. Here we want twice this. Okay? Good. So we are going to put in the integers. 1 times 16 is 16. 16 plus 5 is 21 divided by 16. Here we're going to multiply by simplifying first. So plus 1/4. And now we know that the least common denominator is 16, and the adjustment on the second fraction is 4. So we have 21 plus 4, which is 25/16. I'm assuming they want us to take the integers out. It will be 1 and then 9/16 inches. Is this okay?
That's perfect.
Does it make sense?
It does.
Perfect. Let's move on. Any questions? Anybody on problem 32? Any questions on 32? Okay, so moving on to, what was the other one? 33. Let's move on to 33. Let's take a look at 33. Good. So in 33, is it opening or? Good. In 33, a piece of electrical pipe conduit has a diameter of this. So we're told that the outer diameter is 2 2/3 of an inch, and the wall thickness of 5 5/8 of an inch. What is it inside diameter? So this time we have to subtract from the outer diameter, which is 2 2/3. We have to subtract twice. You have to use the raised dot, because if you don't, it will look like a mixed number. So this is twice the length of 5/18. Put the integers back in. 2 times 3 is 6. 6 plus 2 is 8. Minus, but here we have to simplify. Minus 5/9. The least common denominator is 9. The only adjustment needed is on the first fraction. So it's 24 minus 5, which is 19/9. So that is 2 integers and 1/9, 1/9 of an inch. Is this okay?
Yes.
Perfect. Let's take a look at the last one here. Good. What do they want? Using the accompanying map guide, got it, of backpacking campsites, yes, I love this. Answer the following questions. How many miles is it from site A to site C when going through site B? So I have 10.5 and 5 7/8. I have to add them to see the distance. So the first route is 10.5 plus 5 7/8. John walks at an average speed of 3.5 miles per hour. So that's part B. I just want to copy those. So the speed is 3.5 miles per hour. Divide the distance by his walking speed to determine how long it will take John to walk from side D to side A. Okay, which is the distance, 8 3/4. Perfect. Good. So first of all, we need to determine the distance between A and C going through B. So put the integers back in, 21 over 2 plus 47 over 8. Find the least common denominator, which is 8. Multiply just the top of the first fraction by 4, and we get 84 plus 47, and I get, I think it's 131. Correct me if I'm wrong. Now we have to take the integers out. 1, so it's 131 and 8, 1 and 8, and we have 51. What is it? 54. So is it 6? Yes. So 48. So this is 3/8. And this is in miles. Good. Now, in part B, they're telling us that John has to cover this distance, and this is what he can do. And they're asking us to find the time. Let's look again for a second. How long it will take John to walk from side D to A, which is this distance. Perfect. Okay. So assuming, which is incorrect, assuming uniform motion. This is not really possible. I cannot drive at 30 miles per hour without going from 0 to 30 miles an hour. But because uniform motion means constant speed, that's not possible, right? But we assume that we are looking at a constant speed. But I have to get to that speed in order to keep it constant. And then when I stop, I have to reduce the speed. But we are talking about uniform motion here. Uniform motion has a formula that is distance equals rate times time. They are giving us the distance. So the distance is 8 3/4. They are giving us his rate, which is 3.5. What they are not giving us is the time. So they want us to find the time that he needs with his speed, assuming, this is a big assumption, assuming uniform motion. How long it takes him to cover that distance. I will put the integers back in. 35 over 4 equals 7/2. And of course, I want to get rid of this, and I will multiply both sides by the multiplicative inverse of this number. You must multiply both sides. If you don't multiply both sides, you're changing the problem and you're not getting the correct answer. Sorry about that. So what is the multiplicative inverse of 7/2?
2 7.
Exactly. Good. So then, of course, 7 over 2 times 2 over 7, because remember the properties of multiplication, I can do the order I want. So that is T equals, and here I have to multiply, but not before I simplify, 35 over 14. And this is in miles per hour, this is in miles, so the time will be in hours. Now they're asking us to take the integers out, so this is 2 hours, that's 28, and 7 over 14, which needs to be simplified. And I should have simplified it from here by 7. 7 and 7. So it's 2 and 1/4. 2 and 1/2, of course. It's 5 over 2 hours. So 2.5 hours. He needs to cover the distance of 8 3/4 miles at his speed of 3.5 miles per hour. He needs 2.5 hours to get to his destination. Anything else? Very good questions. Somebody else had another question, or I don't remember. Sarah, is this okay?
That's perfect. Thank you so much.
Thank you. Is there anything else? Anybody? Anything else? Anything else? One more time.
I did have a question.
Please, yes.
I forgot that you can cancel out unit of measurements, just like a factor.
Yes, of course. Yes. That's a very
Okay.
good point. Yes, we can. Yes. Anything else? Anything else? Okay, so in that case, we're going back. I'm going to share my screen. Let me close this one, this assignment. Okay. We are moving on to the last 2 sections. And I want to finish those and review for the test. Okay, where are you guys? Here. Perfect. Okay, so let's see what else is here about decimal numbers. What else we need. Okay, yes, I want to talk a little bit about this. Yes, you're allowed to use a calculator, but it's important to understand the concept. So 14.3 times 0.4. So 14.3 times 0.4. So when we multiply them, we do not have to line up the decimal number. It happens that in this case they do. The decimal digit, I meant to say, the decimal digit doesn't have to be lined up. It happens in this case. So I have 4 times 3, which is 2, it's 12, and I carry 1. 4 times 4 is 16, plus 1 is 17, I still carry 1. 4 times 1 is 4, plus 1 is 5. Since I only multiply by 1 digit, I don't have to do anything else. However, at this point, I have to count the number of decimal digits. So I see 1, 2. From right to left, I go 2 spots, 1, 2. And that's how I get 5.72. Any questions?
Can you repeat why you put your decimal 2 spots?
I have to count the number of decimal digits. I have 2 decimal digits. From right to left, I have to count 2 spots. Is that okay? We'll look at another in a minute. Something a little bit more exciting. Okay, we can do this one too. So 0.4 times 0.9. Again, 4 times 9 is 36. I count the number of decimal digits, 2. So from right to left, I count 2. So that's where I put the decimal point. Is that okay? Is this okay? Good, let's go back. Let's see what else. Okay, let's also multiply these two. I'm gonna go through problems and you tell me what you would like to work on. So negative 450 multiplied by negative 0.02. First of all, please deal with the sign first. So the sign is positive, so I only have 450 times 0.02. So I have 450 multiplied by 0.02. 2 times 0 is 0. 2 times 5 is 10. 0 and 1. 2 times 4 is 8, plus 1 is 9. I count the number of decimal digits. I only see 2. So the answer is 9. Is this okay? Perfect. Okay. Okay, stop me if there is anything that you would like to stop. This is just addition and subtraction that we did. Look carefully. This is a very simple situation. 25.5 times 10, multiplication by 10 or powers of 10. So let me see again. 25.5, yes, I thought so. Times 10. When we multiply by 10 or powers of 10, all we have to do is move the decimal digit to the right, that based on the number of zeros we see. So this is 255. If I had 25.5 multiplied by 100, I would have moved the decimal point 2 spots to the right, 2550. Okay? Let me know if there is anything else. The same thing with 100 here. The number is negative, and I would have moved the decimal digit 2 spots to the right, 26.2. Matt, you wanted to say something?
Negative 26.
Yes, negative, yes. Perfect. Here we have 4 zeros. So I have to move the decimal point 1, 2, 3, 4. I have to add an extra 0. So this would be 80,220. Let me know if we need to write this down. This is a different story. So let's take a look at, and you will understand how easy this is once I explain it. So negative 796,000 multiplied by 0.01. The easiest thing to do is change this into 1 over 100. Why 100? Because there are 2 decimal digits. 2 pieces. The 10th and the 100th. So I'm changing it into this. Look what happens now. All I have to do, cross out the 2 zeros. So the answer is negative 7960. I can do this because this is a power of 10. It's a negative power of 10, but it's a power of 10. If I had 2 or 5 or 15, no. But powers of 10 are always easy. Okay, the same thing here. I'm actually dividing by 1,000. So when I divide 82 by 1,000, or 82 times 0.001, this is 1 over 1,000, which means I have to take the decimal point 3 spots to the left, 0.082. Getting used to these as being powers of 10 with a negative exponent, it will help you a lot later. Good, the same thing, I'm dividing by 10, so it's negative 0.52. Choose from the list below the factor that completes each multiplication. Okay, so let's choose one from here. 1, 2, 3, 4, 5, 6. Which one would you like to work on? You want to work on 5. Let's work on 5. Perfect. So here what happens here. So obviously we have how many spots? 6 is one spot. 1, 2, 3, 4, 5. So there are 6 digits. So we want 2, 4, 6. Is this okay?
Can you do one more of those?
Yes. Choose one.
2.
Sorry about that. Good. So I count. I count the 6 first, and then 1, 2, 3, 4. So a total of 4. A total of 4 is this.
Hello.
Unbelievable. So a total of 4 is this. Because we are dividing by 10,000. In other words, I have to move the decimal digit, the decimal point, I keep saying that, to the left 4 spots. Good. Yes, yes. Find the quotient. Okay, so let's look at some division. So 0.156 divided by 4. Good. Yes, you can use the calculator, but one option would be, first, I want to mention the fact that in a fraction, we do not want decimal numbers. If I don't want decimal numbers in a fraction, obviously I have to multiply the numerator by 1,000. Why 1,000? Because I have 3 digits. And I have to multiply the denominator by 1,000. I cannot simply multiply the top without the bottom. So I have 156 divided by 4,000. And now what I will do, I will simplify as much as I can. They are both even numbers. So I'll simplify by 2 and by 2. And I have 78. So for now we have 78 over 2,000. Again, by 2. And I get 39. And I get 1,000. So this is the simplified form. But look at what just happened. I'm asked to divide 39 by 3 zeros, meaning the decimal point, which is here, I have to move it 3 units to the left. Easy. Yes, can you use a calculator? Yes. That's fine. I don't want to make a big deal out of dividing by 2 and 3 and 10. But this is the correct way to show the work and etc., etc.